Good evening, everyone. Our group will be presenting our capstone project, entitled The Data Journey, Archetypes of Data Professionals. If you are here watching these presentations, then I would suppose that you would be interested in the field of data science and are wondering how to become a data professional yourself, right? Well, obviously, the answer would be to join Escuelabs. You learn so many useful things that I've listed here, and even more that aren't, that can be used to jumpstart your career in data science. However, knowing all these things might still not be enough to become a data scientist because the field is so broad. So what now? What can we do after Escuelabs, and how does one pursue a career in data science? One way to answer that question would be to look through what other data science professionals have done before, which brings us to a 2018 study that analyzed 100 LinkedIn profiles to glean insights on what other data professionals in the Philippines have done in order to obtain jobs in the data industry. However, 100 profiles is kind of a low number and we can do better than that. So instead of 100 profiles, how about 1,695? We scraped LinkedIn for the profiles which included the data professional's educational history and background, work experience, the industry sectors of their jobs, and finally, their skills and certifications.
For the summary of our methodology, we did data collection, data cleaning and pre-processing, EDA, and data modeling. For our data collection, we scraped the profile details in the LinkedIn site using Beautiful Soup, Selenium, and API requests. For the data cleaning and pre-processing, we excluded names and profile URLs and did manual tagging for job categories, education, and certifications. And for the EDA, we analyzed the data based on job categories, working experience, and industries distribution. To understand the educational pathway of the data professionals in our dataset, we tagged the reported educational background into either a college degree, master's degree, and whether or not they are related to data science. Lastly, for the certifications, we used a total of 68 data science-related keywords to identify whether or not each certification is related to data science. We also categorized each of the job roles in our dataset to be data or non-data related. Data-related jobs were further broken down into their categories based on the framework for analytics professionals coined by the Analytics Association of the Philippines. The identified data job roles are shown here. To categorize over 5,000 scraped job roles, we manually tagged 1,200 of the dataset to train an LTK naive-based classifier. Our classifier with an accuracy score of 67% was used to tag the remaining job roles.
Now, looking into our gathered data, we see that only a small majority of profiles have taken formal data science training. But those who weren't able to learn this in school were able to equip themselves with skills via certifications and short courses, which is now being offered by several platforms. Common globally known upskilling platforms are Coursera, Datacamp, and Udemy. But we have local upskilling platforms too. Leading the scene is Project Sparta, which is spearheaded by the Development Academy of the Philippines, and of course, our very own Escuelabs. We've identified the top 10 data-driven industries based on the number of data professionals they employ. Here we see that it's dominated by consulting industries, banking and financial industries, technology, and telecommunications. Altogether, they employ 74% of data professionals in the labor market. This suggests that data teams of the top 10 industries come in larger groups with different experiences and backgrounds, whereas other industries are composed of smaller and more agile teams. Companies belonging to the top 10 data-driven industries employ more data scientists than functional analysts. Their teams also tend to constitute more data engineers. On the other hand, teams of other industries are composed of more functional analysts. Looking at the working experience of the profiles, we see that a typical data professional today has had 4 to 11 years of working experience, with 2 to 7 years of those spent in a data role. On average, they have spent 62% of their working years dealing heavily with data. This suggests that there are a significant number of data professionals who shifted in coming from a different job. And so we asked, what were their previous jobs? Here we see that a lot of them came from the domain of software and research. They have held roles as an engineer or a developer, and their job level ranges from entry-level, associate, or assistant roles all the way up to managerial and consultancy roles. In terms of job mobility, majority of professionals changes roles every 2 years or less. This includes promotions, lateral movements, and company transfers. What this implies is that there's a lot of room for growth in the field. You have a wide playing field to chart your data career, and you have the opportunity to try out different roles in the data job family.
For features that we are using, we use these data points for our model. We also restructured the data through retagging for numbers 1 to 9 and bin number 10 to 12, which is our numerical data, to have an exponential increase to describe recency and experience of a profile. Here we have the flowchart of our data modeling pipeline. After we do all the pre-processing, we proceed to use the elbow method to know how many clusters we would use through the cost and the shape of the elbow. We then created a model and used it to create two outputs, the clustered profiles and the cluster characteristics. So for our model in this project, we use the K-mode clustering model as our data is based on categoricals. And for our parameters, we tried multiple different ones to tune, but we mainly focused on checking the method of initializations of Wang and Cao if they may give us better results. Here's our elbow plot, and we have determined that the best case is having 5 clusters, as this is the moment the model tapers off. In the bottom is the final model parameters we have obtained through our testing. So now we go to our archetypes. Based on the 5 clusters identified, we came up with 5 archetypes for our data professionals in our dataset. These are the shifter, the architect, the purist, the veteran, and the domain expert. The most common of these archetypes is the shifter. They are characterized as individuals without a formal data background who have shifted into the data industry mid-career through taking up a functional analyst role. These people are still at the beginning of their data journey and will require more experience in order to transition into other data roles later on. Many of the shifters have more years of experience before their first data role on average, signifying that they were shifting from another industry. This is evident in the sample profile we are displaying, which is one from our dataset, who was originally from an engineering background before joining a data bootcamp in Esquelabs and later securing a role as a data analyst at Uber. Next, the architects, the cluster of data professionals who are mainly specialized in the data engineering role, a role that requires unique skills such as data warehousing, knowledge of databases, and being especially fluent in programming. We noted that many people who had a background in IT or computer science had the option of leveraging the knowledge into data engineering, which is why many of these individuals have jobs that were tagged as data engineers.
The purist archetype consists of individuals who gain their data-related skills from formal education, and is the cluster with the highest incidence of individuals with a data-related college degree and a data-related master's degree in data science. These individuals likely started their careers with data in mind from early on. Here is our sample profile for the purist archetype. As you can see from this, these individuals are likely to be involved in doing data-related things from the beginning. The veteran is a cluster that looks somewhat similar to the purist, but instead of taking a master's degree in data science, these are individuals who went directly into the field to hone their skills, supplemented by data short courses. Here is our sample profile for the veteran archetype. As you can see, this is the cluster with the lowest amount of experience before taking their first data role, meaning that these people are spending most of their years in the data industry, even without taking a master's degree in data science. Finally, the domain expert is the archetype that consists of individuals with substantial experience working in a specific domain, indicated by years of experience and years of formal education. They bring with them their domain expertise as they transition into a data scientist role. This is the archetype with the highest amount of experience before their first data role, indicating that the domain expert is shifting into the data industry from a rather mature career in another field. As an example, the individual in our sample profile had many years researching physics before becoming a data scientist. With this, we can move on to our conclusions and recommendations.
Our research has shown that data professional jobs are very technical. To get into these roles, you must either have a related educational background or have taken training or certifications that demonstrate you have the specific technical skills needed for the role. For those who don't have background in math, statistics, or programming, taking masters in data science or completing boot camps and certifications are common pathways in gaining the skills. Lastly, data jobs are mobile. Movements occur every 2 years or less, indicating that there's a wide room for growth in this profession. For our batchmates in this fellowship program, should you wish to be working in big data teams and be exposed to peers with various levels of experience and backgrounds, we recommend you to aim for any of the top 10 data-driven industries, such as IT consulting, outsourcing, and financial services. For mid-career shifters looking to break into data, you can use the domain knowledge you developed prior as leverage to complement the technical skills you've learned in this fellowship program. Lastly, for individuals without much experience or education yet aspire to be a data scientist, we recommend you to try a functional analyst role as an entry into the field. We hope that through understanding these different archetypes, you may supercharge your career, whether you're a seasoned veteran in data industry or someone just starting out. Though this does not mean you need to conform to these archetypes, these serve as a guide. Ultimately, it's your choice in how you want to thrive in this revolutionary industry. Once again, we are Group 3, and thank you for listening.